I would strongly recommend making a summary sheet, because basically, if you make that one sheet, right, what, like almost 11 chapters, 11, 12 chapters of GC Leong, you can summarize in one sheet. Okay, it makes it very easy to revise, because you'll need to keep revising this. Like, just by doing it once, you will not remember all the details. You will not remember, like, what is mixed forest, for example, or like which type of weather has mixed forests, or like, or taiga vegetation. What is the humus content like? Like, because it is coniferous, because they're evergreen, you need to make that connection. Be like, okay, it is evergreen, the leaves don't fall, there's less humus. Like, you need to make that summary sheet in order for you to be able to solve questions, because I hope you were able to understand that, at least in terms of quality of questions, UPSC is always going to be tough. UPSC is always going to have tough quality questions. Like, we saw some of the questions that we did yesterday. Some questions you were all able to do well, but there's some questions where most of you were not able to do very well. So I think the way you will get much better at that is if you make that summary sheet. So just try and take time out and make that summary sheet. If you make that summary sheet, it will really help you solve questions. So just a quick roundup of what at least I have planned. What I'm going to do now is we're going to do erosion, deposition, and then landforms. Like, just very quick recap of what all types of landforms are formed by which agents of geomorphism. We'll do this tomorrow. What we'll try and do is figure out about either human geography. Human geography, I'll tell you about just some important statistics. It'll be very factual. I've collected lots of statistics on human geography, like Indian population, or rice, India's largest exporter in the world, second largest producer. These facts can be useful for prelims. So that I will let you know about just the human geography aspect, and whatever remaining physical geography part is left, we can try and finish that. Next week, once geography is over, I was thinking we will do polity. Polity, extremely important. Also something that needs to be revised multiple times before the exam. So polity I'll do, and especially in polity, because I believe that polity, at least everyone has completed, everyone has done at least 1 or 2 times. So polity, I'll focus on keeping the summary very short and focus on doing lots of questions. Like, we'll do lots of questions, because polity can be very tricky. Like, even after, like, I have made mistakes, my friends have made mistakes, I'm sure even you have made mistakes. You can revise Lakshmikant 3-4 times and you will still make some mistakes in polity. At least I have made. But again, polity is extremely crucial, extremely critical to get right. If you can get polity right, every year some 8-10 questions come in polity. And realistically, if you solve 50 questions, 60 questions in prelims, you're through. You're qualifying in prelims. So we'll do polity, and we'll do it with a focus on questions. I'm collecting some questions also, like conceptual questions, tricky questions, which we can do in class. So let's start today's class by looking at the processes of geomorphism, and then we look at landforms, and we'll try and complete that within today's class. Just before that, a doubt on what is a safe score while doing a vision test series. So generally, my aim when I write a test is to consistently try and score 60%. It can be up, can be below, can be slightly higher, depending on the test quality, depending on depending on how your friends have done, maybe. But consistently in any test, try and score 60%. Whether it's a very tough test, whether it's an easy test, 60% is minimum. Okay, because even in UPSC, cutoff like never falls below like 100. Cutoff can be around 98. Last year I think it was around 98, 97, because very tough prelims paper. But generally it is above 100, is around 105, 110. So if you consistently get into the habit of targeting 120, targeting 115 at least, then it will also reflect in UPSC. Because UPSC, even though last year's prelims paper was one of the hardest prelims papers in recent years, okay, like last year prelims paper was harder than previous years. Last year's prelim paper was even harder than that. But even then, cutoff only went from 103, 102, 103 to 98 or 97. Okay, basically, no matter how hard the prelims paper gets, cutoff will never fall below that mark. Cutoff will never fall below that 97, 98 marks. So you have to score above 100 to be sure that you're going to qualify. So you target that in all the papers. Even if test is difficult, test is easy, you have to get 100 plus. And to get 100 plus, you have to target 120. If you target 120, you will get 100. Okay, that's at least what I think, like in every test. And that's how I approach every test at least. And the way this changes how you attempt the paper is, supposing in a particular year you realize that the paper is very tough. Like last year paper was very tough. If you talk to a lot of people who qualified also, they'll say that when they attempted the paper, guaranteed answer, they only knew 22 questions, that much only. Nobody wrote the paper feeling that they knew 50 questions, 60 questions. We are qualifying for sure. In such a paper also, you should know how to attempt. And you'll only get that by practice. So do tough papers. Do tough papers, do easy papers, do every type of paper. Every type of paper, try and solve, because that will help you prepare for prelims, because prelims is very dynamic. It can be easy, it can be difficult, can be whatever. Okay. But yeah, let's start then. Let's start, and we'll keep it quick. We'll focus on making it a summary, and for which I hope like at least revision you guys must have done. Like we'll be doing this from GC Leong and NCRT. So geomorphism is the process of changing the shape, the structure of the earth, the landforms on the earth. That is known as geomorphism. Gradation is the very technical terms. Just keep thinking of these technical terms. Gradation is the changing of the earth's surface and relief through erosion, which is why you have the term known as degradation. Gradation is the changing of the earth's shape and relief through gravity and through erosion. So geomorphic processes, like we said, is changing of the earth's configuration, changing of structure, shape of the earth. Another important term is diastrophism. Diastrophism is a term associated with plate tectonics. So diastrophism is continental building of mountains. That is known as diastrophism, also associated with plate tectonics. Diastrophism, there are primarily three types. Three processes of diastrophism. Orogenic meaning mountain building. Epirogenic meaning continent building. What is the difference between orogenic and epirogenic? Orogenic, there'll be folding. Like Himalaya are young fold mountains. There's layers. They're built on top, layer on top of layer on top of layer. In epirogenic, there is no folding. It's just direct upliftment and submergence. So these plateaus, like African Rift Valley, these are all epirogenic processes. Other forms of diastrophism are earthquakes, plate tectonics. Then geomorphic agent is the next term. Geomorphic agent is stuff like running water, glaciers, wind, which are all responsible for changing of the shape of the earth. Like the agents that cause this geomorphism, that carry material from one place to another. These are known as geomorphic agents. Then endogenic processes. Endogenic processes are again caused by the same two factors which we spoke about. Radioactivity and primordial heat present within the earth's surface. Okay. What is endo? Endo meaning from inside. Okay. So from the earth's inside, what two causes do you have? You have radioactivity and you have primordial heat. Another important factor, especially in earthquakes and in faults, creation of faults, is rotational energy of the earth. Rotation of the earth. Rotation of the earth is responsible for differential moving of plates, leading to faults, formation of faults, especially transform earthquakes. Transform interactions happen due to rotation of the earth. Then next you have exogenic. Exogenic meaning from outside. Exogenic means from outside. So what is the biggest source of energy from outside the earth? The sun. The sun is the cause, and therefore all these agents of erosion are some way or the other caused by differential heating caused by the earth. So if you have wind, if you have ocean currents, these are all results of heating. Like wind goes from high pressure region to low pressure region. Why? Because low pressure region is one that has been heated more. High pressure region is the one which is cooler. At the center of all of these geomorphic agents is the sun. Sun is the one which is responsible for exogenic processes on Earth. And related to this, you also have ocean currents. Ocean currents also same concept. Differential heating. Differential heating is responsible for the origin of ocean currents, and therefore that's also an exogenic process. Okay. Next, you have That processes that are responsible for weathering and for erosion. Oh, before that, one other thing that I forgot to mention, that these endogenic processes are normally said to be responsible for continent building of continents, for upliftment. Okay, and exogenic processes are responsible for bringing them down. So endogenic processes will create a landform, like mountain will get created by the endogenic process of orogeny, and the mountain will be brought back to the surface through rivers, through wind, through sheet erosion, all of these processes. Next, the types, the processes of weathering. What is weathering? Weathering is disintegration, decomposition of rocks. This process is known as weathering. What is the difference between weathering and erosion? Weathering is the process that happens at the location, also known as in situ. In situ meaning at the location. Weathering happens at the location. Erosion, what happens? Erosion, the material is transported and deposited somewhere else. I have a question. On this, which I will show you at towards the end of the class, like so you can all answer. Okay. Now, weathering can be physical and chemical. Chemical, what are the processes? Solution, carbonation, hydration, redox. Solution is when you make it into solution through like dissolving in water. Carbonation is when for carbonates, bicarbonates, they melt in water, create carbonic acid, and melt and dissolve other compounds. That's carbonation. Hydration is when water is added. Redox is reduction and oxidation reactions. We spoke yesterday about how iron to iron oxide is an oxidation reaction, similar to that. Okay. What are physical weathering processes? Physical weathering is due to gravitation, due to differential expansion, due to water pressure. Basically, in all physical expansion, in all physical processes, what happens? The underlying concept of physical weathering is that you will have slight differences due to temperature, due to pressure, due to water, due to solution, whatever. You'll have slight stresses which are created due to these small differences. So, for example, if area 1 of rock is being heated a lot, area 2 of rock is not being heated. Area 1 will expand and contract, expand, contract. These tiny stresses over hundreds of years will break the rock down. Summary of all physical processes is exactly the same. Freezing, thawing, salt weathering, they're all exactly similar. They're all very similar. And basic funda is that you will have these small stresses which are responsible for the breaking. Okay. Biological activity, you know that you have earthworms, you have microorganisms, you have bacteria. These will all break it down. So what are the effects of weathering? You have a process, something known as exfoliation. Exfoliation is exposing of new surface. Supposing there's a rock made up of layers. If first layer is removed, exposing of second layer of rock is known as exfoliation. So what is the significance of weathering? Weathering leads to soil formation. Soil allows life. Without soil, there is no plant, there is no life. Weathering allows for creation of soil. And how is the property of soil determined? Property of soil is determined through the parent material. Okay. The question is salt crystal growth, chemical weathering or physical weathering? It depends. It depends on what type of salt it is. Like chemical weathering would be if that salt can be dissolved, and therefore if it leads to gaps. Like karst topography is the chemical weathering type. Physical weathering is if the hydration process is reversible or irreversible, but this difference is not important. To whoever asked the doubt, this difference is not important, will never be asked in UPSC. The types of questions which can be asked in UPSC, I'll keep showing you. Every day I'll keep showing you questions. We'll solve through questions. You'll understand better. Next is mass movements. In mass movements, some terms are important, like solifluction. Solifluction is when the entire soil is concentrated with water. If there's concentration of soil with water, then the soil behaves like a liquid and soil moves very easily, leading to large-scale destruction. And mass movements can be both slow as well as rapid. In the rapid movements, in these mass movements, what you need to know is whether gravity is acting as an agent of denudation, or whether it is responsible for mass movement, because mass movement is not the same as erosion. Erosion is when you have weathering. Process of weathering takes place, then material is transported through erosion and it is deposited somewhere. In mass movement, weathering is not needed. The material under gravity is directly deposited. That's all. Yeah, so correct, like landslide. Landslide is an example of mass movement because weathering is not a prerequisite. So whether it is weathering or mass movement is determined by whether it is Mass movement or erosion is determined by whether there is weathering. And the way mass movement basically happens is if there is ever a material on some slope, there is some resistance. There is some resistance to its movement due to friction, due to trees, due to some force which is holding the soil or rock in its place. If something like rain, like in solifluction, if there's a concentration of water, or if in landslide there is slight disturbance, or avalanche there is disturbance, then the gravity overcomes the resistance, which leads to mass movement. Then like obviously when there is erosion, erosion is accompanied by deposition. So which is why you have, for all landforms, you have two types of landforms. You have erosional landforms as well as depositional landforms. The same agent can be responsible for two types of landforms. And lastly, soil. Soil quality. What are the factors which determine soil? Factors which determine soil is parent material. Parent material is what is the type of rock. What type of rock is present over there. Okay. Then there is what are the weathering agents? Are the agents like soil, wind, whatever? What is the climate in that area? What is the climate like? What is the topography? What is the rivers like? What is the drainage like? What are the slopes steep? Are the slopes like gentle? Is it a plain area? Is it mountain area? All these determine the quality of soil. And lastly, time. Like how long has the soil lasted? So now let's do landforms. Let's do landforms, and landforms I'll do from GC Leong because GC Leong has covered it in a much better way. So first, for a river, again there are some important terms. There are important terms for rivers which are consequent, insequent, oblique. Okay, which I will tell you once. So consequent stream is the initial stream, the first stream which exists due to rain falling or due to meltwater of glacier. That initial stream is known as consequent stream. Insequent streams are the ones that join the consequent stream. Insequent streams are the ones that join the consequent stream, and often they join obliquely. As a result, you also have various types of drainage patterns. So dendritic drainage is a tree-like drainage pattern. So if you have like a stream and then various streams joining from the side, that is known as dendritic. Then you have trellised. Trellised is where it is more rectangular. If the streams are joining at right angles, if there's a stream 90 degrees, stream 90 degrees, 90 degrees, 90 degrees, these are known as trellised. I'll send the spelling. I'll send the spelling for both dendritic as well as trellised. Dendritic pattern versus trellised pattern. Okay. Now, how does a river act? Like, how does a river erode the material that it carries? This it does primarily in three ways. Okay. First is by solution. Remember, we said solution, action of water. Water acts on the river. Water acts on rocks and it melts the salts. Melts the salts, rocks break, it carries the rocks. Solution. Then it is in suspension. Okay. When the material is suspended, what is the river carrying? River is carrying stones, branches, rocks, whatever it's carrying with each other. They will all rub against each other. So if the stones are rubbing against each other, they will get eroded and they will become like soil, like regoliths, or also it will become eroded material. Then you have traction load. Traction load is all the material that the river is carrying. Like imagine if you're taking rocks that the river is carrying and the rocks are hitting a surface. That will also lead to that surface getting eroded. Like supposing there's a mountain and you have a river which is flowing onto the mountain. Over time, that mountain will get separated into a valley. And the way that happens is in the river, you have all these big rocks. These big rocks from the river are constantly hitting the mountain. And so mountain will get separated. This process, the term for this is known as traction load. All the coarse material like pebbles, stones, rocks, boulders form the traction load, and the traction load hits against these mountains and hits against whatever to create changes, to create erosion. Okay. So as a result of erosion, what are the types of landforms we have? Okay. So erosional landforms are primarily happen during the river's youth, during the youth of a river. What is the youth of a river? Youth of the river is its initial state. Like when the river is young, when the river is in its upper course, when the river is still near the mountains, when the river is in its mountains, it is known as the youthful stage. So what are the landforms of youthful stage? Landforms of youthful stage are primarily gorges, rapids, and waterfalls. Gorges spelling accent or gorges, landforms and so what are gorges? Gorges are like these canyons. Gorges are when you have like a mountain and river is flowing, and due to the river flowing, the depth, the mountain is getting slightly separated. These deep valleys are known as gorges. Okay, like Grand Canyon. Grand Canyon is a type of gorge. Now, gorges can be V-shaped as well as U-shaped. Now, V-shaped is developed when vertical corrosion is much higher than the horizontal corrosion. Okay. Now, when a river will have action on the sides as well as on the bottom. If a river is flowing, like imagine any river between two mountains. River will have action towards the sides. River will also have action vertically. Why? Because of all the erosional factors I told you. When you have these rocks, when you have these pebbles, whatever, they will act vertically also and they will act horizontally also. If vertical erosion is much higher than horizontal erosion, then it will go deeper. These deeper valleys are known as V-shaped gorges. If horizontal corrosion is higher, okay, then valley will become wider. And then you'll have U-shape. So if horizontal corrosion is higher than vertical corrosion, you will have horizontally it will spread. If it spreads horizontally, you will have U-shaped valley. If vertical corrosion is higher, you will have V-shaped valley. Okay. Another important concept in this is something known as river capture. River capture is due to the horizontal corrosion. We just said no horizontal corrosion. Due to horizontal corrosion, stream paths may change completely. Okay. It is also known as river beheading. So due to the horizontal corrosion, a river may go from becoming tributary of one river to becoming tributary of another river. If you've revised this before, you will know exactly what I'm talking about. Otherwise, just refer to some diagram. Search for river beheading or river capture. Okay. Essentially, this is important because you should know that river capture is largely something that happens in the youthful stage, in the initial stage, not something that happens later. And rapids and waterfalls, you're aware, like it's a mountainous part. Like the youthful stage has lots of mountains. So as rivers fall off mountains, it leads to formation of waterfalls. As rivers fall off mountains, it leads to formation of waterfalls. Next, you have the middle valley, middle course, the middle age of the river. When there's middle age, the lateral corrosion, okay, the horizontal corrosion becomes much higher than vertical corrosion. Why? Why does it become much higher than vertical corrosion? Because the speed of the river reduces. When it is young, river is going down a mountain. You're going down a mountain, speed is much higher. Middle course, the slope becomes more gentle, becomes more hill-like. Speed reduces, so then there is more horizontal corrosion. What is the result of horizontal corrosion? You have landforms like meanders, interlocking spurs. You have landforms like interlocking spurs and meanders. What is meander? Meander is that because of the horizontal corrosion, the river changes shape. Like when a river was going straight like this, due to the horizontal corrosion, river becomes more bent. When the river becomes more bent and snake-like, that is known as meandering. And that meandering also leads to something known as interlocking spurs when there are hills and mountains on the sides. Interlocking spurs, I'll send the spelling, just refer to a diagram if you have not seen it before. But all this is there in GC Leong. GC Leong, this is all there, we're only revising. Interlocking spurs. Then lastly, you'll have depositional. Lastly is the mature stage or lower course. In the mature stage, you will have depositional landforms. What are the depositional landforms? Depositional landforms are deltas. Like in India, we have Krishna Godavari Delta, we have Sundarbans Delta. Where are Sundarbans Delta, Krishna Godavari Delta all located? They're located near the mouth of the river, near the seas. Why? Because when the river reaches the stage, the speed of the river becomes so less that all the material, like the river has been collecting silt, sand, rocks, pebbles, all this material that the river has been collecting throughout its journey will get deposited because river does not have the energy to carry these anymore. River has become very slow. This leads to deposition. So delta becomes one of those depositional landforms. Along with delta, then what else do you have? what do you associate delta with? With floodplains. Like Krishna Godavari Delta, very fertile. Sundarbans Delta, very fertile. High rice growth in these regions. So basically, this also means floodplain deposition is there in this region. Okay. Another landform in this area is something known as Oxbow Lake. In Oxbow Lake, what happens is when a river meanders so sharply and to such a high degree that beyond the point the erosion points meet, it leads to a small lake in the shape of a horseshoe getting separated from the river. That is known as Oxbow Lake. And last concept for rivers is something known as river rejuvenation. In river rejuvenation, what happens is due to a rise in the continent or due to fall in sea level, a river which was once mature starts becoming youthful again. Okay, listen to me carefully. At the mature stage, what happens? Mature stage, the slope is low. Slope is very low. We have plains in this area. Okay. Slope is low. The speed of the river reduces completely. Okay. Which is leading to depositional landform. Now, what if due to epirogenic forces, the level of the plain rises? Okay. Supposing the plane rises and is brought from ground floor to first floor, okay, something like that. Then when the water falls from first floor, it will have energy again. Gravity will act again, similar to how it had high speed in the mountains. If there is uplift of a continent, speed will come again due to gravity. This increase in speed due to these epirogenic forces, due to uplift of land, is known as river rejuvenation. Why is it called river rejuvenation? Because the river which was earlier in mature stage is again entering youthful or middle age, which is why it is called rejuvenation, like rebirth of a river. Why does this uplift take place? Uplift take place due to continent building forces. Remember, we said endogenic forces. Endogenic forces are responsible for formation of continents, are responsible for formation of valleys, large plateaus. So these forces can lead to the sea level rising. Related to this, there's an important concept known as nick point. Nick point. Nick point is the point where there is uplift. Nick point is the point where there is, okay. This nick point is also associated with the formation of terraces. Why is the terrace formed? Because earlier, if it was like this, it's like if someone's looking at my video, earlier if it was like this, due to the uplift, it rises. And at this rise, the river falls. This is known as nick point, and the associated thing is terrace. Okay. This technical geographic terms, just remember them. Okay. So now let's go to the glaciation landforms. So again, glaciation also you have landforms of erosion, landforms of deposition. Now, landforms of erosion are again glaciation. Not all the terms are important, but from GC Leong, because some of the terms are very geography optional specific, but still need to just one thing that I forgot to mention earlier was Bhangar and Khadar. Okay, Bhangar and Khadar are unique to India. Bhangar and Khadar are new and old forms of alluvium. Alluvium is this river deposition. This river deposition, sand and silt, very fertile silt, is known as alluvium. Right? So there's Bhangar and Khadar. Bhangar is generally less fertile and Khadar is more fertile. Bhangar is generally the old alluvium, Khadar is new alluvium. Related to this, there's also a term known as kankar or kankar. Kankar is these large rocks. Large rocks are known as kankar. So yeah, let's do the erosional landforms of glaciers. So erosional landforms of glacier, there's something known as corrie or cirque. Corrie or cirque is when you have glacier. Okay. Glacier is embedded into the mountain. That mountain, there is always a deep cirque, that downslope movement. This is hard to explain without a diagram. Let me find a diagram for this. I'll find a diagram and send it instead of explaining in the air. Send the image. Question is there any scope of these terms coming in exam? Generally, no. Generally, these terms will not come in exam, which is why we are also doing it very quickly. But you need to know what these terms are Because in case such a term comes, everyone else in who's qualifying prelims will get it right. So which means you also have to get it right. Which is why like you need to focus on at least doing the basics, these fundamentals. Okay. So next you have circ. Circ is that deep cut. Can you see that deep cut in the diagram? Has everyone opened the diagram? Has everyone opened the diagram? Okay. So in that diagram, if you can see this deepening of that cut, you can see that circ floor, right? So that when you say the circ basin, that is circ. Circ is this deepening caused by the glacier. This deepening into the surface of the mountain is known as circ. Next, areth. Areth, can you see that pyramid-like structure? That pyramid-like structure between two glaciers. Okay, that pyramid-like structure, mountain-like peak, is known as an areth. Next is the glacier. Do you notice the shape of the glacier, the trough being created? Rivers, we said that rivers largely in youthful stage create U-shaped valleys. Glaciers are so wide that they create U-shaped valleys. Okay. If rivers create V-shaped valleys, glaciers create U-shaped valleys because the glacier is itself so wide. Then what other terms are there here? Then you have something known as hanging valleys. Hanging valleys is when when the glacier is gone, when the glacier is completely melted, what remains in that area, and that water as it like just falls like a waterfall, that is known as hanging valley. Like it basically hangs, this hanging valley, when you have the main river or main glacier, this side glacier, you have the main glacier, the side glacier is what is known as hanging valley, because the water just melts from there and falls on the side. So like that's all. That's like nothing more than this is important for glaciers. Just these terms, these basic terms you should know. Next, next is for deposition. Deposition is slightly more important. Okay, so deposition, you have like these various types of moraines. Moraine is generally the depositional landform of glacier. Moraine are these like glacial alluvium, glacial erosional deposit. These are known as moraines. Okay. Now, what is terminal moraine? Terminal moraine is towards the end, like the debris, the depositional form which is collected towards the end of the glacier. That is known as terminal moraine. Then you have drumlin. Can you see that image of drumlin? Drumlin is that oval shape, this oval shape with long tail and short head. If you see the diagram, this oval shape with long tail and short head, that is known as drumlin. Now, important term for glacial topography is it's generally called basket of eggs topography. Like these drumlin structures in particular are known as basket of eggs topography. Basket of eggs topography. Then you have this medial moraine, lateral moraine. Can you see those terms? Medial moraine is the one which is present in between, in the middle. Lateral moraine is the one which is present on the sides. This English term. And lastly, you have outwash plains. Outwash plains is when this terminal moraine is deposited by these small streams. These small streams and channels, when they deposit the moraine somewhere else, it is known as outwash plain. The difference between terminal and lateral moraine. Terminal moraine is at the end, towards the end of the glacier. Lateral moraine is on the side. That's in terms of characteristics, they're quite similar. Let's move on from glacier. Like you were all saying also, it's not very important. Let's go to desert. What are the desert landforms? So desert, the agent is wind. Desert, the main agent is wind. Now, like there are some technical terms for types of deserts, which are hamada. Hamada is rocky desert. Reg is stony desert. Erg is sandy desert. I'm not spending a lot of time because not very important. Now, mechanism is largely through wind. So the wind generally, because of wind is a weaker force than something like water and something like glaciers. Why? Because water is not only action of water. Water along with it carries lots of these stones, pebbles, rocks. Remember I said that lateral corrosion and so on. Okay. So which is why like wind takes a much longer time to erode than something like water. Okay. But given that, what are then the types of landforms that are formed? Okay. The important one is something known as mesas and buttes. Mesas and buttes. Mesas and Mesas and buttes. Okay. So mesa is like this table like structure. If you see the diagram, you'll understand. Mesa is a table like structure, where the rock in the center is resistant and the rest of it is not. So the wind will break it into this table like structure. Butte is this hill, like short rounded hill. If a mesa is made into a rounded form, it is known as butte. Okay. The important one for civil services for desert is the depositional landforms. So depositional landforms is obviously dune. In deserts, you've seen sand dunes. Now dunes can be both moving as well as static. So generally in sandy deserts, in the very sandy deserts, dunes are moving because the sand shifts from one place to another. You have something known as Barchan. Barchan is a crescent-shaped dune. Barchan is crescent-shaped dune, and the points, like dune has these points, correct? You have the center of the dune, and then you have the far points of a dune. Those far points of a dune for Barchan are pointed away from the direction of the wind. Okay, in Barchan is crescent shaped dune with direction of the wind, with the points of the dune pointed away from the direction of the wind. Just that's the term. And if the direction is reversed, it is known as a parabolic dune. These are just definitions. These are definitions for what the dunes are called. Half crescent dune is known as SEIF. SEIF. Half crescent dune is known as SEIF. Then you have transverse dune. Transverse dune is when the dunes are formed at right angles to the wind. Transverse dune is formed at right angles to the wind. Longitudinal dune is formed when wind is in the same direction. As the dune. Oh, and the two other important terms are pediplanes and pediplanes and playas. So pediplanes are these featureless. When you say featureless long, these featureless long plains in deserts are known as pediplanes. And then you have playas. Playas are these salt lakes. Basically, these extremely salty regions which are formed by evaporation of all the water present in that area are known as playas. Basically, if there's ever a question on playas associated with which landform or which region, you should be able to identify that it is desert. Or pediplane is associated with which, it is identified with desert. That you should be clear about. Okay. Then there is karst topography. Karst topography, not extremely important, but we will do the important terms. What does karst topography mean? Karst topography is related to limestone or calcium carbonate. I'll send the spelling. Karst topography is related to limestone or calcium carbonate. Okay, basically the water melts the calcium carbonate and leads to formation of different landforms. Just the terms, the explanation is not very important. The depositional landforms are known as swallow holes, sinkholes, gorges, doline, uvala. These are the erosional landforms. No, this karst is a separate topography. Karst is a limestone topography. And the depositional landforms of karst are stalagmites and stalactites. So stalagmites come from the bottom, stalactites come from the top. Again, I'm not spending too much time on this because not extremely important. And then there is features near the sea, islands and features near the sea. For islands, you just need to know what is the way in which these corals are created, origin of how corals are created, and you have lagoons, how lagoons are formed, how islands are submerged. That part is important. The rest of it is not very important. And yeah, I think with this, and coasts. Last is coasts, like types of coasts. And I think the rest of it we have covered. The rest of it I think we've covered at least enough to start doing like questions. Okay, last is coasts, the types of coasts. Okay. So types of coast, you have two: coast of submergence, coast of emergence. Coast of submergence is when the land sinks. When there is sinking of land, it is known as coast of submergence. Coast of emergence is when there is uplift. When there is uplift, like epirogenic, we said, no? When there is uplift. Important, very important fact. I have seen this question at least in a test series every single year. Western Ghats are coasts of submergence. Western Ghats are coasts of submergence. Eastern Ghats are coasts of emergence. Western Ghats are coasts of submergence. Eastern Ghats are coasts of emergence. Very important. Now, what is the consequence of this? Consequence is that Western Ghats have more harbors and is better for ports. And Eastern Ghats, there are very few port locations. Eastern Ghats, there are very few port locations. Details are not important, but Ria, Fjord, Dalmatian, estuarine coasts are all coasts of emergence. Coasts of submergence, sorry. Fjord, Ria, Dalmatian, estuarine, these terms, just remember that they are associated with coasts of submergence. Then you have coast of emergence. Coast of emergence is when there is uplift of land. When there is uplift of land. Yeah, and lastly, just this like when how reefs and islands go from fringing to barrier reef to atoll. Okay, there's an origin of coral reefs. That part, just have a look at it once. Again, very like not many questions have been asked from this in the past, but it's just a nice thing to know. Okay, the revision part that we had to do for landforms is done. I hope there are, like, at least in terms of revision, it helped you, and there are no like real doubts in any of these. Now I'll just send some questions. I'll send some questions, and we can, like, we'll do at least some 3-4 questions before we complete the class. Do at least the basics.